All right, everybody, welcome to 5.5, using inequalities in the triangle. In this one, you're going to see how sides of a triangle can be determined, how big they can be, things like that, using a rule that you already know, actually. And then one extra little thing, which I think you're going to grasp onto really, really nicely and really easily. Okay, so starting out, one thing that we need to remember is the triangle inequality theorem, which you have learned about before, which says that the sum of lengths of any two sides of a triangle is greater than the length of the remaining side. So if we call this side here A, this side B, and this side C, that means that A plus B has to be greater than C, A plus C has to be greater than B, and B plus C has to be greater than A. What this usually boils down to is the idea that if we take the two smallest sides of a triangle, they need to be bigger when you add them together than the biggest side. Well, we're going to use that information again, but we're going to look at it in a different way. So let's say that a triangle has one side of a length of 13 and another of a length of 16, and we need to figure out the possible lengths for the third side. Well, there's going to be a limit to how small that third side can be for this rule to be held, and there's going to be a limit for how big it can be for this rule to be held. So for our first example, our first direction anyway, let's look at small values of what that third side can be. What's the smallest it could be, in fact? Well, think about this. Let's say that we had this 13 side, and it was kind of closing this way. It was making a smaller and smaller angle over here, and getting closer and closer to being a flat surface with 16. When it got right up to the edge of 16, so that they were almost the same line. Remember, this has a length of 13. How close would this remaining distance be between the 13 that's down here and the 16 that's up here? Well, in order for them to connect, this length over here would have to be about 3, because 3 plus 13 gets us our 16. Now, because we don't want a line, we want a triangle, that side's going to have to be a little bit bigger than 3 for us to be able to make a triangle. Or else, remember, 3 plus 13 equals 16, but we need any two sides of a triangle to be greater than 16. So, when you're looking for the small value, you could even set up an equation or an inequality that says x plus 13 has to be greater than 16. While solving that, we get that x has to be greater than 3. Now, by that same token, we can set up another inequality to find the biggest value of x, because we also know that 13 plus 16 has to be greater than x. Remember, any two sides of a triangle have to be bigger than the third side. So let's say x is the third side. Well, that means that 29 has to be bigger than x. So we have two pieces of information. X is greater than 13, and that 29 is greater than x. Putting those together, we know that 3 is less than x, but x is less than 19. So the side length has to be between 3 and 29 in length. You can either use this picture approach, or you can use the inequalities that we use to figure it out. So to get a little practice, if a triangle has one side with a length of 10 and another with a length of 4, we need the possible lengths of the third side, which we're going to call x. When your third side was short, what type of triangle was formed, and when it was long, what type of triangle was formed. We'll get to that soon. So, looking at the triangle, we have a side length of 4, a side length of 10, and then unknown that we don't know yet. Remember, two cases to investigate. We want one case where x is being paired with the short side, and those two added together will have to be greater than 10, and we want the case where x is going to be the long side. So we're going to have 4 plus 10 being greater than x. So over here, we subtract 4 from both sides. We get that x is greater than 6. And over here, we find out that 14 is greater than x. So x could take on the values anywhere from 6 is less than x, which is less than 14. So x could be anywhere between 6 and 14. Again, I'm just using the idea that x has to be a number such that any two sides added together are bigger than the biggest side. So basically, the short way to look at this is, in one inequality that you make, you want the biggest number that they give you to be the biggest side, and in the other one, you want x itself to be the biggest side. Putting those two cases together, you're going to figure out the range of how big x can be. When you do that, you're going to get all of the results that you need. So, in fact, don't even worry too much about this part. I meant to take it off of the worksheet. You're not going to need that part. This idea up here is the big part to take away from this. All right, other side. In any triangle, the shortest side, this is our next idea. In any triangle, the shortest side is always opposite the smallest angle, and in any triangle, the longest side is always opposite the largest angle. So, list the angles of DEF in order from least to greatest. Well, again, smallest side across from smallest angle, biggest side across from biggest angle. Our smallest side over here is DF, and that's across the triangle from E. So E is our smallest angle. Our next smallest side is 13, which is across from angle F. So F is our next angle in size, and that leaves angle D to be our biggest. So that's how you do that one. For example 2, we look at the angles, and we need to figure out how big this remaining angle is. Not too bad to do. Just do 180 minus 72 minus 39, which is the same thing as 180 minus 111, which is, there we go, 69 degrees, so that's that angle there. So now that we have all the angle sizes in the triangle, we can order the side lengths from least to greatest. Smallest one is across from the smallest angle. Smallest angle is 39 degrees, so we go over there and we find GI. Next smallest angle is this one that we just found. It's across from that side, so our next smallest side is GH, and that leaves, so we have GI, we have GH, that leaves HI to be the biggest one. And last problem we have on here, going back to the idea that we saw earlier on the sheet, not connected to this topic that we just talked about, but one last refresher on the triangle inequality one. If a triangle has a side length of 12 inches and 15 inches, what could be the length of the third side? Well, let's rule a few things out right now. It can't be 2 inches, because if we do 12 plus 2, that's 14, but we need it to be at least 15. So 2 doesn't work. 3 doesn't work for the same reason. 12 plus 3 is 15, which is not bigger than 15. So 3 doesn't work. And lastly, 28 doesn't work, because 12 plus 15 itself is 27, but that means the third side has to be less than 27, which 28 is not. So the only, 27 doesn't work for the same reason, which leaves us with 13. So, the two big ideas again from this section. One, you can use the triangle inequality theorem to discover how big a third side of a triangle has to be, if you know two of them. And two, opposite sides from their angles that they're opposite to correspond to each other in their sides. Smallest angles are across from the smallest side in a triangle, and the biggest angle is across from the biggest side in the triangle. And it's always going to match up that way. Which is why, in isosceles triangles, by the way, those two angles that are the same size are across from the two sides that are the same size as well. Alright, so that's enough from me on 5.5. I'll see you coming up on the series of videos about coordinate proofs. So, I'll see you later.